Hello, everyone, and welcome to The Vertical Space, a podcast at the intersection of technology and flight. We are your hosts, Jim Barry, Peter Shannon, and Luka Tomjanovic, and here we look at the most important forces shaping the market of advanced air mobility with a particular focus on why and how they matter to those building a business in this very exciting and growing industry.
So we built a lot of eVTOLs of almost every configuration you can imagine, and everyone that's out there and some that aren't. And when we went to go study how to put it into production, we spent a lot of time trying to come up with a design that could beat existing airplanes. I was in a lot of design reviews in which I would go, look, we're not going to spend all this money, hundreds of millions of dollars, to come up with an electric airplane that doesn't have the performance of a Robinson, okay? We never were able to do that with battery electric designs.
Hey everyone, welcome back to The Vertical Space and a terrific conversation with John Langford, CEO of Electra. John has over 30 years of experience in this space, so he knows what's been done and believes he has an elegant, smart approach to our industry with Electra. We talk about the key drivers for and what becomes first in advanced air mobility, and how factors such as market acceptance, use case, certification, tech readiness, and infrastructure requirements dictate what type of vehicles will fly first with commercial relevance. We extensively discuss eSTOL, its advantages and disadvantages compared to other proposed vehicle types of today. He explains that most use cases don't need pure vertical or hovering. John explains why Electra decided to use blown lift STOL technology and hybrid electric power. He discusses how there are no mode changes with Electra's aircraft, and thus why he believes Electra has several advantages. We discuss Electra, its unique characteristics, and market fit. We listen to what use cases they're targeting with the soccer field-sized operating spaces, and John's response to Luca's questions of the regulatory path of landing and taking off from a soccer field. He also makes clear that they'll be selling and not operating their aircraft. John mentions that pure electric does deliver on the promise of Illinois, and that the hybrid power may require pure electric in different areas and use cases. We then discuss Aurora Flight Sciences, why they started, what they did for the first decade and their challenges, their pivot and trigger point for their success, the importance of Global Hawk, and their years of subsequent success and their eventual acquisition by Boeing. Listen, we enjoyed this conversation for a variety of reasons, but one standout is that no other guest has referenced as many of our podcasts and guests as John has in this conversation. So John, thanks for joining us, and to our listeners, we hope you enjoyed this conversation with John Langford as you innovate in the vertical space.
This episode of the Vertical Space podcast is brought to you by UAvionics. UAvionics is the leader in low size, weight, and power certified avionics for manned, unmanned, and advanced air mobility aircraft. Let UAvionics help you achieve your goals, whether that be type certification, airspace access, or beyond visual line of sight operations. UAvionics has certified and certifiable communications, navigation, and surveillance avionics for your aircraft. So head over to uavionics.com or Google it to see how you can start flying safer and move your platform forward into shared airspace.
John Langford is the CEO of Electra, which he founded in 2020 to develop sustainable aviation solutions for regional mobility. In 1989, he founded Aurora Flight Sciences Corporation, a pioneer in robotic and autonomous aircraft. Aurora was acquired by Boeing in 2017. John served as chairman and CEO from 1989 to 2019. A native of Atlanta, Georgia, John earned his bachelor's, master's, and doctorate degrees from MIT. While at MIT, John organized and led the Daedalus Project, which in 1988 shattered the world's distance and endurance records for human-powered flight with a 72-mile flight between the Greek islands of Crete and Santorini. Prior to starting Aurora, John worked for Lockheed Corporation, the White House Office of Science and Technology Policy, and the Institute for Defense Analysis. John was elected to the National Academy of Engineering in 2018. He is a fellow in the American Institute of Aeronautics and Astronautics and served as AIAA president from 2018 to 2020. He worked on over 100 aircraft development programs, many of which he organized and led. In 2023, the AIAA awarded John the Reed Award for Aeronautics, the highest honor they bestow for notable achievements in the field of aeronautics. John is a lifelong aeromodeler and passionate STEM education advocate. His family owns Estes Industries, the world's leading manufacturer of model rockets and model rocket engines. John Langford, welcome to the Vertical Space. Great having you on.
It's great to be here. Thank you.
First question we ask everyone, is there anything that very few in the industry agree with you on?
Well, if you judge by the responses to the SFARs that were put out last summer, we at Electra have a pretty different view than much of the industry on what those SFARs said. So I would start with that. There's three big pieces that are fundamental to that in the SFARs. The first is reserves. The second is training, and particularly the use of onboard pilots and 2 seats. And the third is the whole issue of a powered lift category and a special type cert. Our response to the SFARs that the FAA put out, the draft for comment, there were sort of two people who responded in favor of it, Electra and the Airline Pilots Association. And then pretty much everybody else came out against it and saying that it would be everything from an inconvenience to an industry killer. And you've had a lot of the other guests on there who've spoken to that in the past. On our part, from Electra's point of view, I think the issue of reserves speaks to the whole fundamental issue of electric propulsion, how it really fits into aviation, whether it's ready for prime time. And I assume it's something we'll spend a lot of time on today. But I do think the issues on reserves, on training, and on the powered lift types are three things that clearly the industry and Electra probably take different views on.
John, just go into a little more detail on each if you could.
Yeah, it was interesting at the Honeywell Summit, which you guys were at and did a piece on. One of the eVTOL's CEOs made a comment to the effect that a requirement for 45-minute reserves, they couldn't even fly for 45 minutes, much less have 45 minutes of reserve. And we nodded and said, yeah, that's what we've been saying for 5 or 6 years. And so the question of, do you make airplanes fit into the current regime, and that includes the sort of safety regime, or how much do you modify the environment to fit the capabilities or lack of capabilities of the new aircraft? And I think that's really a really central issue. I'd like to spend in just a second a fair amount of time on a quick view of electric propulsion, but I think reserves are really fundamental, and the reserves are not arbitrary numbers that have been made up. They're something that has been developed over many years and proven by experience. They'll probably will need to be somewhat modified for some of the new capabilities, but I think you face a big sort of dichotomy in the aviation world today where the standards of safety are so high in the Part 25 world, and people project that to all other phases of aviation. And then to start right off with saying, well, we have to modify the existing safety regime in order for these new airplanes to work at all, should give people pause. And certainly at Electra, the whole business plan is built around the assumption that we have to operate in today's regulatory environment, in today's airspace, because the way you get a return on an investment is to minimize the amount of time that investment is sitting out there before it can produce revenues. And so our whole business plan is designed to fit into the existing regulatory structure as it is today. And I think that's a pretty big difference between us and most of the other players in the AAM, the new entrants into the AAM market.
John, have you heard any credible arguments in favor of changing the reserve requirements? Is there something about the concept of operations or the flight environments that are different from when those reserves were initially determined? And by the way, do you know the history of how the industry converged on 30 minutes for VFR, 45 for IFR?
Yeah, well, you've asked the other guests that question, and I'll give you the same answer they did, which is no.
Thank you for listening.
So there's no real physics-based argument, and I know a lot of people are going, we're going to be flying short distances, and we're going to know where all the landing sites are all the time. But as a former glider pilot and as somebody at Electra, we spend a lot of time looking at landing sites, and when we talk about Electra, that's a big part of what we're doing is opening up new places to operate out of. And while there are a lot of landing places, they're not infinite numbers of possibilities where you can conduct a safe, non emergency landing. And we are not trying to build a chairlift here, right, which operates from one point to another point and nothing in between. We think that what you have to have is a system that can go anywhere. A lot of what Electra's focus is to decarbonize aviation, but also to expand the places aviation can operate. And if you're going to do that, you cannot have something where you are built around assumptions that you always know where you're starting, you always know where you're ending, and you're operating like a chairlift or something.
You talked about training as the second.
Yes, the Electra airplane is built with 2 seats up front. It is intended as a single pilot operation, 9-seat aircraft, but there are 2 piloting stations up front. Now, that initially came from just listening to our customers, many of whom said, look, the kinds of things we want to do with this airplane includes building time as part of the pilot training pipeline, right? And so our customers want to use it as a training tool, a tool for building time as pilots move up from ab initio trainers, which that's not what we're building, but we assume you're already a licensed pilot by the time you get into this, but that you build time in order to move up towards the 1,500 hour number. And that's part of what the customers want to see. And so that's very consistent, I think, with the FAA's approach that while they think simulator training is great, particularly for upset training, they still want you to have time with an experience, with it, be able to do check rides, right, in the airplane. And I agree with that. I certainly have heard the arguments, oh, well, F-35s are single-seat airplanes, but most of the military airplanes historically, even the single-seaters, there's some 2-seat version that you work up to, and the military doesn't start you off in those super high-end airplanes. So we looked at it. We think it's just extremely prudent to be able to use this as a training device, even though it's certified and we expect most of the revenue operations will be flown single pilot. The third is the powered lift certification piece, where, it goes back to the V-22 thing. And this is one of the questions that I ask anecdotally, but have never really gotten a great answer to, which is the V-22 and the AW609 have very long, very expensive development histories behind them by teams of people who were well-funded and knew what they were doing and have struggled to get into certification. The AW609 is still working on that, and there are unique things about airplanes that have these mode changes that fly from vertical flight profiles to horizontal flight profiles in that transition. And while a lot of that will certainly be masked in the flight control systems, it is still a very different animal. When we built the Electra airplane, one of the key advantages that we think is that there are no mode changes in what we're doing. It's a conventional airplane with a wing from the beginning of the flight to the end of the flight. And that is the basis of a lot of what we think are the both operational efficiencies, which translates into cost, and also operational safety.
You said in one of your presentations, John, caught my attention, there's a reason why the president's flying in a helicopter and he's being escorted by 2 V-22s.
Yeah, and we saw that yesterday at Manassas. The president came out to give a speech close by, and Marine One flew right into the terminal there, and it was a helicopter older than, well, not all of us on this call, but many of the people who work at Electra, those helicopters are older than. But yeah, absolutely. If the concept's not safe enough for the President of the United States to fly on, why is it safe enough for me to put my kid or my mother on?
So, John, an elemental stem cell question. What comes first in advanced air mobility? What drives the need for the first commercial vehicle?
I think it all starts with an air vehicle that works. And I can't think of another time in aviation where we're talking about certification and huge expenditures on new infrastructure for an airplane no passengers have flown on. And we have no passenger feedback about whether people are even going to want to fly on these aircraft. So I'm a big believer that what comes first is you got to make the airplanes work, and that means not flying them just in private tests, but actually in public use.
So the first point you have, you need to be able to roll out a vehicle that's actually going to work. So many of the use cases in advanced air mobility, you would think, could be more economically and safely addressed with eSTOL versus eVTOL. Talk about that a little bit. And you've already highlighted in this conversation, there's a lot of challenges with vertical lift. You haven't talked about cost yet, but I'm sure you will. But there's a safety concern in the transition. But it seems like an awful lot of the missions in regional air mobility and in other areas that they can be better served by the eSTOL.
Yeah, let me talk a little bit about how we came to the idea of Electra. And it was through building a lot of eVTOL airplanes. At my previous company, Aurora Flight Sciences, we can talk more about Aurora in a second, but we were primarily a rapid prototyping operation. We built all kinds of advanced aircraft concepts, and that's what we offered to our customers. And we did electric airplanes really from day one, or we tried to, right? The very first airplanes we started building in 1989 for high altitude use were intended to be electric originally. In fact, battery electric, using one-shot lithium thionyl chloride batteries to get to very high altitude, so you didn't have to build an air-breathing propulsion system that worked at 85,000 feet. In about the mid-2000s, so starting in about 2002 and then flying in 2009, we did a hybrid electric airplane called Excalibur for the Army that had a gas turbine and a generator and 3 electrically driven lift fans that also had batteries. And then we did a program for DARPA that was called the XV-24 Lightning Strike, which was a very large turbine driving generators, 3 megawatts worth of electricity, driving 28 fans buried in the wing. It ended up being a tilt wing to get the high speed and the VTOL working together in that. And as part of that program, we also did a subscale demonstrator, which was purely battery powered and autonomous. And we used that to demonstrate the full flight envelope. And then we went from there into a program with Uber, which for an airplane that we called the Pegasus and Boeing called the PAV. And then we did a proprietary program with Porsche. So we built a lot of eVTOLs of almost every configuration you can imagine, and everyone that's out there and some that aren't. And when we went to go study how to put it into production, we spent a lot of time trying to come up with a design that could beat existing airplanes. I was in a lot of design reviews in which I would go, look, we're not going to spend all this money, hundreds of millions of dollars, to come up with an electric airplane that doesn't have the performance of a Robinson, okay? We never were able to do that with battery electric designs. But what did happen was some guys up at MIT, John Hansman and Mark Drela, and one of their grad students, Chris Corton, began to say, hey, look, for most use cases, it does not have to be strictly vertical, right? What you really care about is the runway independence. There are some cases where you have to hover, where you need that pure vertical or you need that pure hover capability. You always will, and so those will be the province of helicopter designs. But in most other cases, every other case that doesn't have that absolute requirement for vertical or hovering, you're better off with the physics of a wing. And a wing is essentially a thrust multiplier, whereas with a VTOL design, all of the lift is provided by the thrust. So, you have to have thrust higher than your weight. And in a normal airplane, what a wing does is act as a thrust multiplier. So if you have a 10-to-1 lift to drag ratio, you can get away with 1/10 the thrust that you would need if you were trying to take off vertically. And that gives you a physics advantage that is why most airplanes that you see are what we call CTOL, or use a wing throughout the entire flight envelope. The science that Electra is harnessing in this is a technique called blown lift, which is something that has been around for 50 years or more, since NASA in the 60s and then 70s really pioneered it, and the French and the Japanese, and there were some Air Force programs that looked at this. By blowing the wing, bathing the wing in carefully designed flap systems and with the higher velocity air from the propulsion system, you could get lift coefficients that were multiples of what you could get from a conventional sort of static configuration system. So instead of getting a lift coefficient of 2.5, you could get lift coefficients approaching 10. And if you can do that, you can fly much slower. And if you can fly more slowly, you can take off and land in very short distances. Blown lift, as it was developed in the 60s and 70s, was always that it was being done with gas turbines. And gas turbines are basically, well, if you look at the history of CTOL airplanes, we've gone from 4 engines to 3 engines to 2 engines, and people would go to one gas turbine if they could. Obviously, they don't because of the redundancy need to be able to lose one at takeoff, but you essentially pay for the maintenance cost by the gas turbine. So the blown lift wants continuous blowing across the wing in an infinite number of propulsors, and the gas turbines want to have one propulsor. And so that was fundamentally the problem of the early blown lift designs, was they were never economical matching with the propulsion systems that are available. The insight that Hansman and Drela and Korten brought to this was that distributed electric propulsion actually solves that problem. And so with the electric motors, you can now have good specific power and good efficiencies on a number of small propulsors, and the exact number you have to optimize, but a lot more than 2. We have 8 on the airplanes that we're doing, which matches very well to the requirements of blown lift. And so that's the fundamental physics behind what Electra is trying to do. It gives you a 2 to 3 times the useful load fraction compared to a vertical lift design for a given vehicle weight and a given mission. And then we spend that advantage in a couple of ways. We spend some of it in, we have a better useful load fraction than a VTOL design, but we also spend some of it in things like development costs and in manufacturing costs, that we're focused on how you reduce the non-recurring costs by not being highly vertically integrated, but by using more COTS components. And I don't mean commercial COTS, just other aerospace level components. And we can talk more about that. And then in the recurring, we have not settled yet in the production of how much is going to be composite and how much is going to be metal, but we don't have to use the ultimate lightweight solutions that the VTOL folks get driven to, because we have that physics advantage that we can spend in a couple of different ways. And overall, we think it's going to make a much more cost-effective proposition, both for the operators and as a business, than anything else we have been able to come up with. And that includes, as I said, looking at pretty much every eVTOL concept out there. So that was the genesis of when I left Aurora and started Electra about 3 years ago.
So, John, you were looking for a design and you saw this insight that distributed electric propulsion enables a really effective blown wing design. What beyond that helped you refine that down into a product and commit to that product? What mission set did you want to go and target with this aircraft?
Well, we started with the whole suite of urban and regional air mobility missions. One of the beautiful things about the eSTOL, particularly when you couple it with the hybrid electric propulsion, essentially the blown lift gives you the very short runway capability, and the hybrid gives you the ability to go long distances. And in this case, long distances is hundreds of miles. And so we look at the whole set of missions. One of the things we announced this week is we've crossed the 2,000 pre-orders or letters of intent for the 9-seat airplane that we're developing. And you just look at the range of folks who are buying that and what they are planning to do with it. And it basically breaks out into helicopter operators. Our launch customer was Bristow, one of the world's premier helicopter operators. The people who really understand both the pluses but also the minuses, particularly in terms of cost and noise of helicopters today. And we believe we can operate at 70% less direct operating costs than the helicopters they're flying today. And to get in and out of all of the heliports, for example, that ring Manhattan. And so the first people who are really interested in that are the helicopter operators, right? Then we move into the second category, sort of regional air service providers who want to expand the number of destinations that they go to. The kinds of things that we're offering, if you can get in and out of a soccer field sized location, there are a lot of things you can do around the world. Our level 0 requirement, as we call it, is to be able to get in and out of the Wall Street heliport, right? That facility is what we have chosen as sizing our capability. That's where the 300-foot by 100-foot operating space comes from in our requirements, is that existing piece of infrastructure at the Wall Street heliport. And there's space at the other heliports that ring Manhattan for that as well, although like at 30th Street West, you can't actually fly directly into that today. There's a barge that's big enough that would have to be refurbished, and there's a horizontal space parallel to the river at 30th Street that is large enough but has a temporary building in the center of it. But the Wall Street heliport you can fly in and out of today is the idea. And everybody in this market is talking about the airport shuttle mission to go from Wall Street to JFK or to Newark or whatever. That's what Blade does today. And we start with that mission, and we can certainly do that mission, and we can do it at significantly lower cost than Blade is doing it today with the helicopters. But then we can keep going with the airplane, and you can go to the Hamptons or to Martha's Vineyard or Boston, or you can keep going further and you can go to Washington, D.C. We spend a lot of time working that route between New York and Washington, because if you look at that today, it's about 4 hours at a minimum, no matter how you go, whether you drive, take the train, fly commercial. It's all starts at 4 hours and goes up, depending on what kind of delays you may encounter. And the only way to really save time is to get in closer. This is not a case where going faster in the airplane really makes that big of a difference. You can take a private aircraft from DC up to New York, but you're going into Teterboro or Westchester, and you still got to get down to Manhattan. So our view is you've got to be able to get into Manhattan with whatever device you're talking about, and that's what our level 0 requirement is. Once you can do that, then you can go all kinds of places. You can go to places like Santa Monica, which are existing airports, but which carriers like JSX can't get into today, but which they would love to access, and which we can because of both the space and the noise that the quiet operations and the short field operations. We'll be able to do non-interfering approaches into places like into big airports, JFK, but we'll also be able to operate off of the tops of parking garages, which will allow us, we think, to get into places like Tyson's Corner, which is a couple of miles from where I'm sitting. It'll allow us to operate out of big warehousing distribution centers. It'll allow us to go into destinations like islands that don't have airports, that might have ferry service or helicopter service, but don't have an airport for a fixed-wing service. There's actually a lot of those out there. Obviously, it allows you to do every road is a runway. Today, roads are emergency runways for airplanes, of course, but in the medical evacuation or in the defense applications, you use a lot less road than others. And the 300 by 100 foot is about the size of a soccer field. And if you go and look around the world at how many soccer fields there are and where they are, it's amazing.
If I was building an aircraft that was range constrained and I could only effectively go 25 or 30 miles in my mission, then yeah, I would focus on these urban centers and finding a way to make that mission profile work from downtown to the airport and all of that. But that comes with so much baggage. And you have an aircraft that is far more versatile. And so why even focus on those missions first? The last few things that you mentioned, going to places that people want to get to, but there isn't a small airport there, to me, that seems like such a layup for you. And why not focus on that first? Or maybe you don't care. Maybe you're just in the business of selling airframes and the customers will fly them where they will.
One of the other things that we are adamant about is that we're not the operator. We're not trying to be our own user. We are going to establish other customers, and that's part of that 2,000 pre-orders. Is it's something like 40 different customer organizations, and one of the beauties of those pre-orders is it puts you inside an NDA veil that you can operate, where you can tell them what you're really doing and they can tell you what they want to do and what they're really doing and the things that they want, the features that they want on their product. And that's basically what we're focused on, is listening to the customers and making sure we deliver what they want. At the same time, you have to have a visionary element as well to it, as the Steve Jobs iPhone analogy, right? That people aren't really good at market research because it doesn't really help you on things that don't exist today, because people don't really know what they want if they've never had one. And so we're balancing that, right, between the existing missions, which will be the early adopters, some of which are even literally direct replacements for airplanes that are in the fields today, and the expansion markets that are enabled by the new capabilities that this airplane offers. We think that's one of the things that makes it such a robust business plan, right?
Yeah, I think you're bringing forward a versatile aircraft that you put it in the hands of the customers and let them show you how they're going to use it, rather than some of the other companies in the space are being so prescriptive with this incredible new set of flight capabilities, and yet they have a very narrow vision for how end users are going to access it. I'm a big fan of letting the industry discover how customers are going to use it by putting a versatile platform in their hand and something that's really multi-mission capable, and then watch them apply it and learn from that.
We absolutely agree with you.
What is the regulatory path to landing an aircraft in a soccer field?
Well, you can do it today with a helicopter, right? It's the same structure there is on operating the same flight rules and stuff as helicopters are today. The joke in the helicopter field is you can land a helicopter anywhere once. and honestly, as we look at our business plan, particularly for some of the things like where you're dealing with establishing commuter services to towns, to communities that don't have an existing airport, or you're going to do package pickup or delivery to not just between distribution centers, but even to retail stores, that we think that the local regulations will be an important part of this. And that's why we go back constantly to the noise, right? And why we go back constantly to the need to get these things out there and begin to demonstrate. And I think what happened a few weeks ago in New York, when Joby and Volocopter did demonstration flights off of the Wall Street heliport, and they were very warmly received. And there's always some laws of unintended consequences, right? What people said, hey, that's really, that's really quiet. That's great. All these other guys, right? Let's say now that option exists, we're not going to let into our space. That may be one of those things that you see.
John, I want to ask you a quick question, given you brought up the noise. What's your noise signature versus a Joby?
Well, I don't really know what Joby's noise signature is. And I'm still figuring out what ours is. But
I saw a presentation you gave that compared it to helicopters and the significant difference to helicopters. And there's probably people listening to the podcast right now, some of whom may be critics of eSTOL. So give a little bit of a flavor. First of all, what's the noise difference? Would electric eVTOL companies say, I have a significant noise advantage over eSTOL, or at least a hybrid eSTOL, which you have? And then just give us a quick rundown on what would the critics of eSTOL say overall?
Well, let me start out with the promise of lower noise is definitely one of the promises of electric that I think electric can deliver on, right? There's a lot of hype and promise around electric aviation in general, much of which I think will be very hard for people to deliver on. And we can talk about that more in a second. But I think noise is one of the ones that really will, because the motors are definitely quieter. If you have a lot of small props, you can have lower tip speeds, and then the design of the props has advanced quite a bit. So there's no question that these things are going to be a lot quieter. Will the difference between the eVTOL and an eSTOL pure electric mode, will you be able to tell? I doubt it. I don't have specific numbers today. It's all aspect, angle dependent and stuff. But I will say that in the flying we're doing today, we do have a chase plane, and you never hear the electric airplane if the chase plane is in the air. We are collecting noise data on that, and it's great, and we're super excited about that. I, I think that the electric airplane promise of lower noise will be delivered on by everybody. On the hybrid, obviously, we have a generator on there, a turbo generator in our case. It's small, and we're working to make it quiet. On the two-seat tech demonstrator that we're flying today, it was designed to be inexpensive, so that turbo generator is not particularly quiet. But the airplanes are designed to be flown, and we've tested this. That's why we did our first flight purely electric, because we are working to make sure in all modes it's extremely quiet, but we recognize that there are some cases when you want to be completely quiet, and so our airplane can operate without the turbo generator on. And the analogy I give on that is with a Prius, right? When you pull out of the driveway, you're probably operating purely electric, and when you get out on the freeway, the gas engine kicks in, and that's how you get the range. And I think operationally, you're going to see a similar thing with the hybrid airplanes. In cases where there's an extreme noise sensitivity, like some of the military missions or some of these close-in neighborhood missions, you'll probably will be flying purely electric. For the part where you're low. The other big thing, of course, besides emitting noise is how much are you emitting at the source, and then what is the trajectory, right? One of the ways that the big turbofans really benefited noise reduction on current jets, of course, is that when you had two of them, you climb a lot faster than the older jets did, and therefore you get away from the ground, and therefore you expose a lot less surface area. And the eSTOL does that as well. With the steep approaches in both for takeoff and landing, that's another factor in how you minimize the ground exposure. And it's also another thing most people don't realize about the eVTOL airplanes, which is that everybody pictures them taking off and landing straight up and down. That's not how helicopters work. But the big thing on the eVTOLs is you take off vertically, but then you've got to get on the wing as fast as possible.
Let's talk about the eSTOL safety case and how you are going to approach safe, slow flight. Let's take final approach with the aircraft. What is final approach speed, and what are the safety concerns that you and the team have had to overcome with that? And what do you expect is going to need to be accounted for in the certification process for this? And we can talk about the slow speed control, we talk about wind shear, talk about power loss on final approach. Walk us through that.
Sure. One of the interesting things about a powered lift airplane, about the eSTOL operation, is that the stall speed is no longer a function just of the geometry of the airplane, the way it is in a normal conventional CTOL airplane. What's the flap setting, right? And that's going to pretty much determine the stall speed. In our case, it's also a function of throttle setting because of the blown lift. With the blown lift, you're flying at speeds considerably below the power off stall speeds. We are expecting to be operating 30 to 35 knots in the approach regime of these airplanes. That means that if you're coming into a place like the Wall Street Heliport, you have to have multiple levels of redundancy in the powertrain, and that is one of the beauties of distributed
So,
electric.
so
So
your
in
approach to safety is that we're not going to allow the power to fail through redundancy and reliability.
Yeah, there's 8 motors, there's 4 batteries, there's 2 generators, and there's 1 turbine in those, and it's sized so that if you lost the turbine on a critical part of the approach, you have more than enough battery capability, even if one of the battery systems fails, one of the strings, one of the buses, you can lose 2 motors in any scenario. And that's to handle the extreme STOL. And obviously, one of the other beauties of this design, at its heart, it's a conventional airplane with a fixed wing. And so um, a complete power loss situation in a battery vertical lift airplane, you're going to come down. And in the Electra eSTOL concept, you're going to glide down. That's a much safer situation. We saw that just last week in Loudoun County, not far from here, a caravan coming out of Dulles. And so we think that's an important safety feature.
What are the other aerodynamic risk factors in slow speed flight, in the traffic pattern, on final, that your aircraft needs to be designed around?
Well, obviously, one of the things about flying slow is wind and turbulence. One of the really great things about the electric propulsion, and this is again why we think it's the marriage of distributed electric and blown lift that really is the enabler to make all this work, is that you can now use the different electric propulsors as part of your control system. And in fact, we do that in the design. The differential thrust, for example, is mixed right in to the yaw control and also into the roll control in the airplane. And it's actually a strong pitch actuator as well. So you have tremendous control effectiveness that you don't have in a normal airplane where the controls get squishier the slower you go and ultimately you lose control authority. That does not happen on these blown lift airplanes. That's one of the advantages of this, is that you have very powerful control actuators all the way through the flight envelope, and we plan to use them. That's one of the ways you handle gusts and turbulence and things like that.
And so, how does this apply toward preventing one wing from stalling and causing a spin, and et cetera? Will this system be designed to account for
Yeah.
that and prevent that as part of the envelope
Yes.
protection?
So it is power by wire, first off, and then the entire airplane is a fly by wire. And while I think pretty much you get arguments about how much autonomy people have in the AAM space, but I think pretty much everybody buys into the idea that it's a fly by wire system. And so much so that we often don't comment on that or talk about it. But I would just note that at the moment, there are no Part 23 certified fly-by-wire systems. There are in military jets, there are in bigger airplanes, but the certification piece of that is important and is significant. It doesn't have the challenges of autonomy, the unknown pieces, but it also shouldn't be taken for granted. What you get out of that fly-by-wire, of course, is the ability to have protection throughout it, just as you do on the A320 or the big jets. And that'll be a big part of this.
Okay.
Absolutely.
Okay. And then, with respect to my last question on this, is low level wind shear. What does that present for this type of very slow flight? What type of risk does low level wind shear present? The airplane perhaps finding itself on short final, an increased sink rate.
Yeah.
What do you need to be especially wary of at these types of speeds, and how do you solve for
Yep. That is one of the things that we are looking at. It's related to the other piece of this, is the precision touchdown part. That it's pretty easy to take off in 150 feet on a 300-foot space. It's pretty easy to take off in those conditions. And landing, if you need only 100 or 150 feet of ground roll, that's not too bad. But if you've only got 300, you've got to hit the space exactly. And so that's one of the real, that we see as one of the challenges in this. And that's where, while there's no autonomy per se in this airplane, there's a lot of automation and a lot of work is going into the pilot guidance and exactly what roles the pilot is playing and the flight computer is playing, hitting a precise touchdown point. There is no flare planned for what we're doing. Okay, so we come straight in. If you have an aim point, we're going to hit that. But your point is, well, do you know the atmospheric profile between here and there? And that is a research topic on whether we are going to, in some cases, need a LiDAR profiler or some kind of atmospheric profiler in these very, very short spaces. We are trying hard not to because we're big believers in very light infrastructure, but we have not ruled out that you might need to put some kind of atmospheric profiler at these very small spaces, particularly if there's large building obstacles or stuff around. So you could feed forward basically in the flight control system what you were coming up to essentially in real time.
Right. So you're saying it's really these extremely small landing spaces where this becomes stringent, because otherwise, if there's wind shear that day and you're landing on 1,000-foot runway, you just increase your approach speed like another airplane would, and you account for it that way.
Yes, exactly.
John, tying back to one of the comments that Peter made earlier about the market opportunity outside of these 300-foot balanced field lengths, have you given thought to the idea that maybe this is too complex tackling some of these issues and there's enough of a market opportunity in some conventional missions where you're introducing an aircraft that has significant direct operating cost savings? So why not go and utilize existing 2,000-foot runways and avoid these kinds of safety issues that we just talked about and go serve those missions? And there's plenty of those. What is the benefit of having the capability to land on a 300-foot field? And what does that translate directly to market opportunities?
We've looked at this. It's a great question, and we've looked at this and sort of, I'll broaden the question to how you use blown lift. And the NASA X-57 and the Electra eSTOL set out to use blown lift in two different ways, right? Essentially, what the physics of the blown lift do is make the wing look aerodynamically like it's larger than it physically is. And we use that to have a large wing, which gives slow speeds and therefore short takeoff and landing. And the X-57 was focusing it more on CTOL mode and then have efficiencies in cruise. And I think that where you set that knob depends on the mission that you're trying to do. We looked at, do you want to just go after the caravan market? But our analysis says we can beat the caravan economically and also have this helicopter-like flexibility to get in and of helicopter-like spaces, the 300 by 100 foot space. We think that the market for that is really large. And
yeah, I'd be really curious to understand a customer of yours that's in the logistics space, that's in the caravan space, for instance, today. How do they think of the added benefit of this kind of short field takeoff and landing capabilities, and whether they would be eager to go through the trouble of setting up a private field and then creating, presumably this needs to be an available service, and so you need to be able to go in and out in all weather conditions, including IFR. And so that means developing procedures for those airfields. So why not just go to a nearest 2,000, 3,000 foot runway wherever your current operations exist and utilize an aircraft that is much cheaper and easier to operate?
couple answers to that. The first is that in our analysis, it's not a lot cheaper than the actual cost for being able to do both what we would call sort of a very short field urban air mobility mission, short field, the helicopter analogy mission, versus the sort of caravan mission on that. And our analysis is that we can do both. But the kinds of things we're looking at, the time savings, I go back to the time savings comes from getting in close, from starting and ending your journey close to the customer's point of origin and point of destination. And yes, there's an argument that, there's lots of underutilized airports in the U.S. Yeah, and most of them are places people don't want to go. Okay, that's why they're underutilized. And their warehouse is not on an airport, and there's 4,000 warehouses in the Amazon network alone or the Walmart network alone, and you've got 10 or 12 of those players in the U.S. economy. So you literally have tens of thousands of these middle mile logistics places that you would like to go. You're not going to build conventional airports at all of those. Are you going to be able to take a piece of the existing parking lot and stripe it off and fence it off and operate aircraft out of there? We think the answer to that question is yes.
Well, that's actually one of my questions is if you have a customer that has these types of facilities, and maybe they're well located next to a highway network, but they want to bring an air capability into those locations and they have the parking lot or they have open space. Walk us through what it would take for them to be able to fly in and out of there. Do they have to go and deal with zoning and county ordinances? Does it happen at the state level? I think a lot of us in the audience know what the FAA has to say about this. Paint that picture for your types of customers. How easy or hard is that going to be for them to do?
Sure. Well, yeah. Well, and you had Dave Stepanek on from Bristow, and Dave talked about a lot of this in his interview. What Bristow is looking at is not necessarily flying an eSTOL airplane onto an existing oil and gas platform. That's probably going to stay as a helicopter mission, although Electra also says, well, here's how much a barge costs, and a barge that you can operate our airplanes off of is actually not an expensive proposition. But be that as may, Bristow's current market is to expand into exactly that, or in current vision, and I'm not putting words in Dave Stepanek's mouth, he said this on his podcast with you, is exactly to expand into some of these middle mile kinds of things. And who better than helicopter operators to address those questions that you're talking about? We do not have the answer to every question that you answered in there, but you can do all of these missions today with helicopters. It's just not economically feasible, and with the noise, we think not very sustainable in that. But you could do air service with helicopters into these distribution points. But we think for the middle mile, you need to do a couple of 1,000 pounds, and we think the economics begin to really work at this size of airplane more than some of the smaller UAVs. Now, having said that, I mean, some of the small delivery drone guys are really moving into the scale and commercial service. So obviously, we're watching very closely what's going on in Dallas with the stand-up of wings operations with Walmart and things like that. Big supporters, big believers in that. And I think we're all watching. What's the community reaction really going to be to routine drone deliveries in residential areas? We're hoping it's where everybody goes, oh, they notice it the first few times you do it, and then it goes to a background effect.
One question that I wanted to ask was, to what extent, John, you have considered general aviation as an interesting use case? You mentioned the three up front, but I haven't heard GA, whereas that to me was a really interesting market.
Yeah. Well, GA it goes back to a lot of your autonomy guests that you've had on and discussions. At Aurora, we had a program called Centaur, and Aurora still has that going, which is a DA-42 that was modified to be an optionally piloted airplane where there was a human in the left seat and a robot in the right seat. And we did it in a way that it didn't void the normal category certification of the airplane when you put the robot in. And we spent a lot of time making the robot removable and in a way that didn't void the normal category cert. So you could fly it manned in a normal category. You could fly it robotically in an experimental category, and we demonstrated that. I personally flew on one of those, and it's pretty weird sitting behind the robot while the robot flies it. There was a safety pilot, of course, on the airplane, but all they did was avoid other traffic, right? That was their role on that, was the detect, see, and avoid. And so I always thought that the real role for autonomy in the U.S. airspace system is really in the revitalization of general aviation. I think that's where it's going to ultimately make a huge difference, because if you look at it for the last 50 years, it's been a steady decline of the number of rated pilots. And it's basically because it's, learning to fly safely in the United States is a little bit of stick and rudder and a lot of procedures. and that's where a lot of the cost, the proficiency, and I'll just call it the hassle comes from. And that's the place that I think autonomy can help the most. So I'm a big believer on general aviation. When I was at Aurora, we were looking at what it took to get an STC on the automation package. And when you talk to Rob Rose, a lot of his comments are very familiar because we looked at all of that and worked on all of that at Aurora with the goal of getting to a general aviation airplane that you could fly with the kind of training and proficiency that goes into a driver's license, and not what you currently have to have for.
You brought up Aurora. Tell us some highlights from Aurora that you think apply to advanced air mobility that you think our audience would be interested to hear about.
Well, the first comment I would make about Aurora is that it started out to be an environmental company. That the mission of Aurora Flight Sciences when we started in 1989 was to do robotic airplanes for global climate change research. And for our first decade, that was pretty much our exclusive focus of trying to build new tools for atmospheric scientists to probe the stratosphere. And that turned out to be challenging, primarily in terms of the financial support that is out there for climate research. People seem to have lots of opinions on the climate, and it's proven to be remarkably difficult to build a company around the environmental research tools and the exploration of the stratosphere. Aurora pivoted about 8 to 10 years into its history to being what I would call more conventional UAV markets, meaning that we got into the defense sector prior to 9/11. And the program that I think really made Aurora, which a lot of people probably don't fully appreciate, was Global Hawk. We bid that as a program to DARPA or DARO back in 1994. And the only requirement that they put out was a 10 million unit flyaway price. That was the firm requirement. We took that seriously and we bid that, and we told them, here's what we think you can do for a 10 million UFP. Bob Mitchell, who is one of the absolute both aeronautical and management geniuses of our business, who was the president of Teledyne Ryan at the time, built the airplane the Air Force actually wanted. And of course, they won that. Aurora pivoted quickly and got onto that team as building composite parts for Bob and his team on the Tier 2 Plus. And then it went from Tier 2 Plus to Global Hawk, from DARPA to the Air Force, from Teledyne Ryan became Northrop. And then 9/11 happened, and all of a sudden, the Global Hawk was a very large program. And about 2 weeks before the 9/11 attacks, Aurora had put in a bid to Northrop at the time to build all of the composite parts except the wing on Global Hawk, and we had won it. And all of a sudden, that was just a huge program. It was very painful, a lot of learning and rapid growth into that. But that was the program that really made Aurora transition from being a small shop that had been pursuing the environmental market into the serious player it became in the aerospace market.
And John, how has Boeing benefited from the acquisition of Aurora? What was the rationale behind that? Some would say that one of the reasons that this transaction happened was because Boeing wanted to kill the D8 double bubble aircraft who might otherwise compete with the 730s. What do you think about that?
Well, I'm a huge admirer of Dennis Muhlenberg, and Dennis did a great interview again on your show. And I think in that interview, a lot of Dennis's vision and enthusiasm really came through very clearly in that. And we were part of that. Dennis was out to transform Boeing. He realized that just because you're the best in the game today doesn't mean you will be in 50 years. And our job was, part of that portfolio was to be a disruptive innovation force at Boeing that was looking at generations of airplanes in the future. And Dennis, I just think, is a terrific visionary. He was the driver behind the Aurora acquisition. And so Aurora's role was to become an autonomy center, a prototyping center. Boeing had a lot of aspirations. Boeing did not and still does not have a Part 23 division, a division that can do Part 23 airplanes. And at various times they've said that's not a market we want to be into, but other times they have been interested in it. So there were a lot of pieces that combined into there. Absolutely true that the D8 was the thing that got that round of the discussions that it led to the acquisition did start with teaming discussions on this NASA advanced concept demonstrator back in 2016 or so, came out of the N+3 program, and the D8 was a program that had been led by MIT and that Aurora had worked on and was very interested in. But that was a piece of the discussion. Aurora and Boeing had a number of previous programs for a number of different customers, several of them in high altitude, long endurance things where we were both competitors, but also we were suppliers to them on high altitude programs. What the world came to see as Phantom Eye, there were programs before Phantom Eye, but the Phantom Eye was the one that became publicly announced and flew. And, Aurora did the wing on Phantom Eye. We did all the engine testing. This was back in 2007, 8. So there was a pretty long history of collaboration working for and with Boeing before the discussions that were kicked off in 2016 that were in fact centered initially around the D8, but broadly they were centered around Dennis's vision of how you built a great aerospace company for the 22nd century.
How do you think that plan is shaping up?
Well, I don't think it's any secret that Boeing has had some tough times. The MAX and COVID were a double whammy that hit them and all the big players particularly hard. I'm impressed. I think Aurora's doing well under Boeing, and I was really pleased at the AIAA SciTech just a couple of weeks ago here that the DARPA TTO director on stage publicly commented on how well he thought the Aurora Boeing merger and integration was going. He said, usually we see big companies buy the little companies and then smother them with bigness. And he said, I don't see that happening at Aurora. I see Aurora doing really well and, keeping, his words, keeping their small company mojo while still doing a good job of reaching deep into the Boeing system for talent and resources. And I think when your customers are saying that, that's what you want, right? We're all in business for our customers. And I was really pleased to hear that. So I think that's a great testimonial for everybody who's worked hard to make that integration work.
One of the comments you made earlier, I'd like to get your further thoughts on Aurora being great in research and development, but never really building more than one of anything. And then to see you move into Electra and starting a company that really is very much product focused. What are some of the insights in terms of commercializing technologies that you have learned along the way at Aurora that you internalized as you started to build out Electra?
Well, the company culture is something that is very difficult to change in any entity. Even in small organizations, particularly in large organizations, it's hard to change the culture once it's locked in. And you get really good at doing one thing. And, Clay Christensen said that your disabilities are a byproduct of your strengths, right? That what you're good at also defines what you're not good at, because you have all these systems and processes, in Aurora's case, that are set up to do new things quickly, but not to do the same thing over and not to support products in the field and stuff like that. It was something that at Aurora, I always kind of regretted that. I mean, I think that to make a real impact, you have to not just invent new things, you have to fuse them into the world where people can use them to make a real impact. And that's what I wanted to do with Electra. So Electra is not at all competitive with Aurora in terms of company mission.
John, you've had a lot of disciples from Aurora who are in advanced air mobility. Who's doing the most interesting work?
One of the things I am most proud of from the Aurora experience is what I call the Aurora Diaspora, of people who came to Aurora right out of school, for whom Aurora was their first job, and I guess that means I was their first boss, who have gone on to be CEOs or founders of companies. The list is like 15 or so. It's amazing. And a number of them have been on your shows. So Brian Yetko, one of the true stars of his generation, who was one of the most rapidly advanced people in the history of Aurora, ran the R&D center in Cambridge and then was the head of all the product development. He's now the CEO at Whisk, but Paul Aramenko hired him out of the aero department. His first job was on the GoldenEye at Aurora. He's had an incredible career at Google and Airbus and now Universal Hydrogen, and Billy Thalheimer at Regent, Adam Woodworth, who was our go-to guy for small UAVs at Aurora until Google lured him to the West Coast, and now he's the CEO at Wing. It goes on. One of the bigger ones was In Situ.
Let me ask you a quick question, John. If we had Brian and Billy in the room right now and you closed the door and said, okay, guys, here are the things you're doing really well, and here are a couple of things, you should take a look at. What would be one or two things they're doing really well? What are one or two pieces of advice you'd give to Brian and to Billy?
I wouldn't try to give them advice. I would ask them for advice. I would say, you tell me.
That's a
what
good
I'm
answer.
Part of being successful is having good ties and loyalty in all directions, right? It's not about burning people down to build a successful company. It's about helping everybody reach their full potential. And we always said that you hire on talent and then you find a role for people in the business. And I think the string of people who have gone on to start their own businesses or become CEOs of either their own business or a business that somebody else helped start is something that I'm very proud of and that speaks well to that.
It's such a universal truth. And now you're embarking on a similar journey with Electra. When you look at that journey, how do you see the capital requirements for bringing Electra.aero's first product to market and into reasonable scale production? How is this going to compare to what an eVTOL project? We all have pretty good examples and familiarity with what those cost. How much capital have you raised so far for Electra?
Well, one thing my mother taught me, you never talk about money in public. So I'm not going to give you a straight answer on that question. I will say that the total that we're looking at is based on things like what Pilatus spent to bring the PC-24 into certification. And Pilatus is one of my favorite companies. I think they are just a fantastic example, and their airplanes are wonderful. And they did the PC-24 for somewhere around 400 million or something like that. And I think that is a reasonable number to bring something in this class range into certification. That's a 20% of what some of these other guys are spending on this. And frankly, I don't know how they have 700 people.
Yeah, I mean, to get to certification, if you can do it for about 400, I'd say that's 25% of the cost of what these other players are going to take, maybe 20%.
So we've asked you a lot of questions, John. Is there anything else that we haven't talked about that you'd like to discuss?
Yeah, I wanted to just touch on the STEM and diversity and inclusion element of industry, which is one of the things that I am really passionate about. We touched on it a little bit in that how you grow leaders and how you help people develop to their potential. But that starts really young. And I am a huge believer in both the sort of workforce development, which is the pragmatic way to look at STEM, and then the sort of it's the right thing to do sort of morality angle of STEM. And I think that is just so important and foundational to everything all of us in this industry are doing. I grew up in the 60s when Apollo was on the evening news every night. It was sort of the really good news story of, of the 60s, with a lot of other traumatic stories going on around it, and it attracted a whole generation of people into the workforce. Today, we don't have that as much as we did, and we can't take for granted as an industry that people are going to want to just flock to what we're doing. I think we're all made up of total aviation people and true believers, but we can't just depend on that cadre of folks. We have to be evangelists in this for our profession. And that's part of why I've been very passionate about programs like First Robotics or like the Team America Rocketry Challenge, and why our family has gotten involved with Estes Industries, because I see the hobbies like model rocketry as being incredible STEM development and workforce development tools.
John, 5-10 years from now, how is the world different than most people are expressing it? You've heard, it sounds like just about all of our podcasts, and you're hearing them pontificate on what's going to happen the next 5-10 years in this world of advanced air mobility. How was your view different than what you're hearing from most of our guests?
Well, first, I will caveat that the reality is I have no idea, right? Because it's really tough to have a crystal ball like that. I tend to think, though, that being a big student of history, that I look at the VLJ market, I look at the commercial drone market. I lived through the hype and excitement that surrounded both of those. And if you look at those, you think, well, there'll be one or two players who will emerge from this in sort of a dominant position. There'll be a handful of zombies, and there'll be an awful lot of roadkill. I think the big outstanding question for me is whether the eVTOLs are going to end up being the aeronautical version of the Segway. And there was a great article in Wired magazine a few years ago that was titled, "Well, that didn't work. The Segway is a technological marvel. Too bad it doesn't make any sense." And it goes back and dissects I'll call it the rise and fall of the Segway, which was an amazing invention by an amazing person. Dean Kamen is truly remarkable. And what he's done in his career, and particularly with First Robotics, I think is nothing short of amazing. But the Segway we weren't going to be walking anymore because we were all going to be on Segways. And that's not how it played out. So I push those as cautionary tales, and I guess that's my big question of whether you're going to see a lot of the eVTOL stuff end up as aeronautical segways.
What advice would you give to our listeners who are starting companies with all of your experience?
I agree that it is a remarkable time for innovation and thus for entrepreneurship in aerospace. So I absolutely encourage and support that. My advice would be not to get captivated by chasing unicorns. That the idea that it's how much money you raise, that's the goal or the metric, that's wrong. I believe that the goal here is to build sustainable, viable businesses. That means they have to have customers and revenue and ultimately earnings. And I think that's what you've really got to focus on when you build a business is how am I going to get to revenues and earnings and not just some kind of paper valuation. That is the encouragement I give students and people when they ask about it.
This has been a great talk, John. Is there anything else you want to add, or would you like to wrap up the podcast in any particular way?
No, I think we've covered a lot of stuff, and I look forward to your skillful editing to make sense of to try to make us out of this.
Well, I got to ask, and I'm not sure if you'll answer it. You've heard so many of the podcasts. What's your favorite?
Wow, that's an excellent question. I like a lot of them for different reasons. No, I'm not going to give you one absolute winner. I think, to me, the beauty of it is being able to hear the whole range of voices, right? Of being able to listen to folks like Dennis Muhlenberg or Bob Pierce at the same time we're talking to people like Brian and some of your other guests. I think you're doing a great service for the community, so I appreciate it.
John, thanks for being on. It's been great having you.
Thank you.
All right, that's a wrap for today. Thank you for listening to the Vertical Space Podcast. Reach out if there are topics that you would like us to discuss, and goodbye until the next episode. Unless mentioned, this podcast is in no way endorsing or promoting any person and or company mentioned, and all opinions within the podcast are solely that of the presenters. The Vertical Space makes no guarantees, warranty, or representation of any information given in this podcast. Any information given is for informational purposes and should be used at your own risk. This podcast is for general, educational, and entertainment purposes only.